Imagine waking up tomorrow and discovering that artificial intelligence can finally walk. Not inside a computer, not trapped behind a screen, but physically walking through your world. It can see objects, understand its surroundings, recognize people, and decide what to do next. For decades, AI had a brain without a body. That limitation is beginning to disappear. And when intelligence gains the ability to physically interact with reality, everything changes. Think about what your brain does when you simply look at a cup. You recognize it, understand where it is, reach for it, and adjust your hand automatically. For humans, this happens without thought. For a machine, it is an enormous challenge. Because the real world is messy, unpredictable, constantly moving, and full of millions of tiny variables. Traditional robots were powerful, but they usually worked only when the environment behaved exactly as expected. But physical AI is being designed for something much harder, understanding the unpredictable real world. Its cameras become eyes, its microphones become ears, its sensors become a sense of touch, and its AI becomes the brain connecting all those signals together. Instead of following millions of rigid instructions, the robot can begin interpreting what it sees. If something goes wrong, it can potentially recognize the mistake and try another approach. And that introduces something traditional robots were never truly good at: learning from experience. Now imagine one robot learns something, and thousands of other robots can learn from it. One machine discovers the solution. A network of machines could potentially share that experience. That changes the speed at which artificial intelligence could learn about the physical world. Humans learn individually. Machines could potentially share certain experiences across an entire network. Every factory could become a classroom. Every laboratory could become another source of experience. And eventually, the question may stop being how intelligent AI is. The more important question becomes, how much of the physical world can it control? At first, the benefits could be enormous. Robots could handle dangerous and exhausting work. They could enter places where sending a human would be too dangerous. Imagine a rescue robot searching through a collapsed building after an earthquake. It maps the environment, detects danger, searches for survivors, and changes its plan as conditions change. But the same intelligence that makes robots useful could also transform the workplace. Today, automation mostly replaces repetitive tasks. Tomorrow, the boundary could become much wider. Because a humanoid robot doesn't only provide strength, it can potentially combine strength with intelligence. And that combination could create an entirely different kind of worker. A machine doesn't need sleep. It doesn't need weekends. And it could potentially operate around the clock. Once hardware becomes affordable enough, the economics of physical labor could change dramatically. Construction could accelerate. Manufacturing could run longer. Dangerous jobs could become safer. Agriculture could become more automated, with robots working continuously across enormous fields. Laboratories could run experiments day and night, while machines perform dangerous or repetitive procedures. And eventually, these machines may enter the most private place of all, our homes. It could prepare food, clean rooms, carry objects, and assist people with everyday tasks. For elderly people, it could become an assistant capable of providing practical help every day. But then we face a question that technology alone cannot answer. How much should we trust in intelligence that can see and move through our private lives? A robot in your home could potentially understand your habits, conversations, routines, and surroundings. And physical intelligence creates physical consequences when something goes wrong. If an AI writes something incorrectly, you can delete it. A physical mistake can be much harder to undo. That means the future of physical AI will depend on something even more important than intelligence: safety. Engineers will need reliable sensors, stronger reasoning, human oversight, and rigorous testing. Governments may also need entirely new rules defining what autonomous machines are allowed to do. But if those challenges are solved, civilization could enter something completely new. For thousands of years, civilization depended on human hands to build almost everything. But imagine millions of artificial workers capable of performing physical tasks at enormous scale. The cost of building things could fall. Construction could become dramatically faster. Scientific research could accelerate as machines perform experiments continuously, without needing to stop. But perhaps the most powerful change comes when robots stop learning only from humans. What happens when robots begin learning from one another? One machine discovers a solution, another improves it, then an entire fleet inherits the improvement. At that point, AI would no longer simply answer questions. It would actively participate in reality. And the transformation might happen so gradually that most people barely notice it. One robot appears, then 100, then thousands, until one day, the world simply feels different. Because the biggest AI revolution may not happen when machines become smarter than us. It may happen when intelligence finally gets a body and starts building the future with us.